So check 1 2. Maths exam is tomorrow. Let's do some maths. I'll be doing maths and requests as well. So anybody from the question, anybody in the Student Hub Discord server, that's a server that you can access by clicking on the Student Hub Instagram. Just search at @the_Student Hub, and you can access the free server. There's already 10,000 students there on that server. You can access that, and you can send questions in the CSEC Maths channel, and I'll answer them. Anybody, I'll prioritize the questions from there. I'm streaming. I hope I'm streaming. Let's just check the chat. So nice. Yep. So press like on the stream, take a snapshot, share it with your people. There's some people who would enjoy this little session before exam tomorrow, so you can let them know. Really and truly, now is my premium class for students who are in my classes. But say I hit them a little live for everybody, so everybody can take a little balance too. So we'll be doing random questions, topics that you all want me to do, I'll be doing. So I'm gonna write that on the screen right now. Why is someone calling me? Hello? Yeah. Good night. I'm in the middle of a class, live right now. What's that? Oh, I don't remove anyone. That's the admin. But right now I'm online on YouTube, so you can just search Cohen Spring on YouTube and join the class there. But we'll work out everything after. Yeah, no problem. Yeah, sorry about that. The stream's current battery is lower than recommended. Open. I don't know how to do that. Y'all, if it blurry, just Triggs. Oh, I also have the question bank open here. Question bank. So if you all want me to do multiple choice questions, let me know. I know we're taking a little while to get started, but once we get started, we're inside. If the quality of the stream is low, just hit the double the three dots at the top right hand corner and increase that. Increase your quality. You're supposed to be getting all the way. Yeah. You're supposed to be getting all the way up to 1080p. Alright, I'm just trying to get the chat everything in order. Yeah, they say do the multiple choice, do paper 2 please. 720 trigs and circle paper 2. Alright, let me switch it up. Like do a paper 2, a paper 1, a paper 2, a paper 1. So there's this. What's the latest past paper this website have, boy? Now if I see any questions pop up in the Student Hub Discord, I'll be doing those questions first and foremost. Let's try this Jan 2017 paper 2. I'll bring this up here. Zoom in, y'all should be seeing that paper nice and bold there. So this happened in January 2017. What y'all think about this paper? Paper is 2 hours and 40 minutes. This happened just before the syllabus switched. So, but I would organize it for you and let you know what you know. So I'll tell you what you could take away from this, you know. Like the sets question in this not involved. Everybody, don't forget to press like, don't forget to screenshot. Am I sticking or is the stream running well? Taking a little while to get everything in order here, boy. So you're lagging? Why am I lagging? Stream health. Stream status. Scroll down. I have no idea why I'm lagging. I wasn't lagging for when I went on. Alright, if it's blurry, just increase the settings. Just increase the settings. A sounding soft. How about now? I just want to make sure everything good before I start. We've been on for like 8 minutes trying to get everything in order. Check, check, check. That should be good. I don't think it have any filters on this. Yeah. Alright, so these first questions you all should be able to do. My advice for you all is make sure and know how to use your calculator for these questions. The calculator that I recommend. So you can just plug this into your calculator straight away and get the answer. Do I have that calculator up here? No. So all good for these. Let me go down. What about these algebra questions here? Very simple, right? Scrolling in. Still low. I don't understand why my volume is still low. All you raise up all your volume. Trouble is this. The volume's supposed to be real good day. Check, check, 1, 2. Yeah, volume's supposed to be good. Alright, let me see if I can do one more trick with the volume. It's taking long to get started, but oh my gosh. Upon a compressor. This might increase the noise, but I should be louder now. How about now? Is the volume better now? I'll let me know. So these things easy. Just people saying it easy. In situations like this, you'll just be like x minus 6, x plus 6. Because you're getting the working that most teachers will use for this is where you show that you found the square root of each one of them. Since this is called difference of two squares. And then you say therefore x squared minus 36 is equal to x plus 6, x minus 6. Easy thing, easy thing. You all could do the quadratic. You all could do the quadratic. Quadratic similar. This 5, you're getting, well, 2 by 12 is 24, negative 24. So you want two numbers that add up to give you 5, but multiply to give you negative 24. So the two numbers will be plus 8x minus 3x, right? Then you factorize. Four. Put this back immediately right here. And I have videos on every single one of these topics. Minus 3. You're getting a number that when multiplied will give me back these original pieces there. So now the chances that of a quadratic coming in one of your papers tomorrow is like 99%, right? So that's factorized. So there's probably going to be something with factorizing. I don't know why YouTube defaulting the quality to low. You could always increase the quality. Given that this is equal to that, find the values of A and B, expand, and find what A and B is supposed to be. Simple stuff. We want to scroll down to some of the tougher topics. So at the ending of the paper, Now, this paper, how many questions in this paper? This paper has 11. That's not how much you're going to get right now, eh? Let me tell you how much you're going to get right now. Yeah, you are actually going to get 1, 2, tomorrow, 3, 4, 5, 6, 7, 8, 9, 10 questions. These are what we consider like the hard questions, and these are what we consider like the basic questions. So this question is relations, functions, graphs. This is geometry and trigonometry. This is matrices and vectors and matrices. So we want to look for these questions. Now this paper has 11 because there's a difference. This was before the syllabus change. All right, so this is transformation matrices. Let me see if we could damage this question. I want to get rid of all these things from off the screen. I'm gonna just see if I can do this, boy. What is this app? Final scene wants that different, this and that on the screen. Lumen PDF is that thing, I didn't know what. Alright, not working. Try Google Docs. Alright, not working. Are they taking forever? So let me begin to do the question. Why is them opening up this up? So doing this question. I'm going to say exam in 2 days. Exam tomorrow. It's not exam tomorrow. I confused though. So the matrix T is that maps the point this onto that. So what I would immediately examine here is what is going on with these numbers. Nothing changed with that number. So to me, if nothing is changing with this number, nothing is changing with the x, I should just put 1 there. You all understand how transformation matrices work? And this number went from positive to negative, so I would put a -1 there. Watch how this will work, eh? So like if I have 1, 0, 0, -1, 2, 3, this is going to be equal to 1 by 2 is 2, and 0 by 3. You all understand how the multiplication work, right? I have lots of videos on matrix multiplication and thing. 1 by 2 is 2, 0 by 3 is 0, so you're going to put 1 plus 0, 2 plus 0, and on this side you'll have 0 plus -3. So in the end you'll end up with 2, -3. That's the only way you can go from this original 2, 3 to the 2, -3. From 2, 3 to 2, -3. Why is in the chat if you all get that? So you could either do it like that. I think the majority of students who would have gotten this out will do it like this. C0, 0, D, like actually show the working. 2, 3 is equal to 2 is equal, and actually work it out now. So you get 2C plus 0 by 3, which is 0, right? And then you'll get 0 by 2, which is 0, plus D by 3. In other words, that's 3D. And so C2, yeah. So you have 2C and you have 3D here. But you can compare this now to 2 and -3. Therefore, 2C is equal to 2, C is equal to 1, and 3D is equal to -3. D is equal to -3 over 3 is equal to -1. All right? Y means yes, if you understand. Press, you'll close off the chat, press like on the video, bring back up the chat. By doing that, more people will get notified from the channel. Determine the image of -5. Determine the image of -5 4 under the transformation T. Oh, so we're gonna use, yeah, just now make all the things go just now from the screen. Close off these two things, it's not working good. So, determine the image of negative 5, 4 under the transformation T. What does that mean for us? What does that mean for us? So, it means given that we have the transformation matrix already, what will happen if we put negative 5, 4 underneath the transformation? Yes. You will end up getting 1 by negative 5 is negative 5 plus 0. And this negative 1 will change the sign there. So you'll end up getting negative 5, 4, negative 4. In other words, the same way how this remain the same sign and this switch sign, this will remain the same sign and this will switch sign. Why isn't it chat if you get that? If it's not clear, you need to dub, it's on your end. You need to go up in the top of the screen there and click these 3 dots and increase the quality of the stream. You're supposed to get 1080p 60 something. Describe fully the transformation T. What is the transformation T doing, class? What is the transformation T doing? So let's go back up. Let's not go back up. The transformation T was actually 1, 0, 0, negative 1. So if I need to determine the transformation, or describe fully the transformation T, I need to examine what's happening to these guys. I think the first one was 2, 3 or something, and it went to 2, negative 3. What it was? Yeah, 2, 3, and it went to 2, negative 3. So what that mean? That means, like if we draw it, it was 2, 3. I understand now, plotting it on the graph to kind of show you. And it went to 2, same 2, but negative 3 on the y-axis. So this was the first point, and this is the image. What do you think happened there? How would you describe this? How will you describe this? Now, I'm going to check a different audio, and you all will tell me if it's better, because I don't like people saying the audio wasn't coming through good. Just give me a second while I say. Why is you all describing the image there? Check 1, 2. Balance, left, right, volume. I hope that will just make once that old noise. Let me see what the chat's saying. Chat's saying reflection. You all got an increase in the volume. The chat is saying reflection, which is correct. Somebody changing my settings on this mic. How about now? But people saying it good on their end. So I don't know what's going on with the person who's saying the audio thing. I hear it normal. Everybody's saying no. So it's just as one person I'm fighting up my mic here. Everybody's saying reflection, which is cool, but if you put reflection, it have big fat 2 marks here and you get all. So if you just put reflection, you might be lucky if you get 1 mark. So you should put a reflection. T represents a reflection in the x-axis. Understand? It reflects in the x-axis. And to explain transformation matrices a little more, There are different styles of transformation matrix. They're all based off of this matrix. What we call this matrix? The identity matrix, right? We call that the identity matrix. Hopefully you're seeing that. No, you are not. Yes, you are. I just clicked it off. So that we call that the identity matrix. The identity matrix means that if I multiply any matrix by the identity matrix, I will get it back. It's like if I multiply 3 times 1, I get back 3. So that's how the identity matrix works. But when you start to interfere the identity matrix, like spike it with little negative signs or change wrongly ones and things happen. So like if I put a negative sign here, when this becomes a transformation matrix that flips stuff in the y-axis, x-axis. Y-axis. In the y-axis. We last transformation matrix that we was doing. Our last transformation matrix as well. The one we was just doing. I think it was 1, 0, 0, negative 1 was here. Now notice when the negative 1 and the underneath, it's reflecting in the x-axis. Because it went, remember the point went from this to this. The y coordinate went from, I think it was 3 to negative 3. It was a reflection in the x-axis, although the y coordinate changed. But if I put the negative sign, here, this represents a reflection in the point would have gone from this one to this one. It reflects in the y-axis. Why isn't it chat if you understand that? There's more. We can do stuff like this. So you all could check out one search Cohen's bring a transformation matrices, or experiment with this yourself. Make sure you know this for your exam in case this come. We can do stuff like this. This represents a reflection in the line. Y is equal to x. Or we can even start to throw negative signs on these guys and see what happens. So, and there's this kind of transformation as well. What do you think this will do? If I make the number like 2, if I had a point like 3, 4, all of a sudden I will end up with 6, 8. This is a enlargement with a scale factor 2. So transformation matrices is basically that in a nutshell. What we doing to the, for CXC, what are we doing to the identity matrix? What are we doing to the identity matrix to change the coordinate? Thing like hyperpage just come in. So do circle theorem and bearings. All right, let's just do our next question. I think I'll be able to cover more work if I do in a multiple choice. So I'm gonna do some multiple choice now, and then I'll come back to our next paper too. So I believe we did vectors and matrices last time. Let's do some. Which one of these topics y'all wanna do? Geometry and trigonometry, relations and functions. Pick one or two. Yeah, Javish, hold it down. Bless up. Let's do some geometry and trigonometry. In an open field, Lucas walks. In an open field, Lucas walks 18 meters towards the south of the field, then turns and walks 24 meters in an eastern direction. He then returned via a straight line to his original position. What was his total distance walked in meters? I know CXC had some kind of walk, this question back in the days. All right, he walked 18 meters south. Because this is north, then this could be south. So he walked 18 meters, this is where he starts. Then he walked 24 meters to the east. This question is testing you on one thing. Then he returned via a straight line to his original position. So what do you think is coming here? So this was 24. What do you think they're testing you on? In maths tomorrow, 100% sure you will see one of these types of triangles. 3, 4, 5 triangle, or a 5, 12, 13 triangle. So these are common triangles, common ratios. So if you, or you may see like 8, 6, 10, which is each number here multiplied by 2. And this will just be revision for people. I can't teach everything from scratch. So if this is 18, like 3, you multiply by 6, 4, you multiply by 6. So 5 multiplied by 6, this has to be 30. Sorry. 3, 6, oh yeah, 30. I'm looking for 30 here, but they ask for the total distance. So the total distance will be add up this. This question is really 2 marks, so it can't really come for CXC. When you add up 18, 24, and 30, but the idea comes for CXC. That's why it's in the question bank. When you add it up, 18, 24, and 30, you're actually getting what? 72. D as the answer. So it's the questions in the question bank designed to test you on all the possible techniques that CXC brought within the last 10 years. So it is like it helps to help you study, know how much you know now. Which of the following is a representation of Pythagoras' theorem using the triangle below? This is as easy as it gets. This x has nothing to do with anything. Pythagoras' theorem has to do with the sides of a right angle triangle. The square of the hypotenuse is equal to the sum of the square of the other two sides. C squared is equal to a squared plus b squared. So 2 is a. 2 is a. Let me do our next one. Let me do our next two. So using Pythagoras' theorem and trigonometric ratios, which of the following is the same as sine squared plus cos squared x? Now this is tough, but a question like this came in the paper 3 years ago. Now this for advanced people, if you're doing advanced, it's supposed to be easy as can be. Number 3, you don't even need to blink. You just sine squared x plus cos squared x is 1 immediately. This is just food. Right? But if you're not doing that maths, what you're supposed to do is realize that the sine of x is the opposite. Opposite is a. Remember that? SOHCAHTOA. Opposite is a over the hypotenuse is c. And the cos of x is supposed to be adjacent b over c. So if they're saying sine squared x plus cos squared x, you just square both. So this is really a squared over c squared plus b squared over c squared, which is the same as a squared plus b squared over c squared. And a squared plus b squared, we just realized from before that a squared plus b squared is the same as c squared according to Pythagoras' theorem. This came from SOHCAHTOA. So this is a combination of SOHCAHTOA and Pythagoras' theorem. Once again, the level of difficulty in this question is high, but once you understand how to do this question, you're starting to become in the game to knock off questions quickly in your multiple choice. So B is 1. What is the length of BC in the triangle below? What is the length of BC in the triangle ABC below? BC. This is BC. Question like this comes all the time. All the time. What is the length of BC in the triangle? Oh, by the way, let me check the Discord and see if anybody sent a specific question for me to do. So yes, I got a question. I'll do this question next. It's a question on vectors and matrices. What is the length of BC in the triangle below? Well, BC. This is the right angle. This is the angle in question. Notice we have nothing to do with the hypotenuse, so I immediately know it's going to be tan. So I'm looking for something with tan. It had to be one out of these two. Anyhow. So this is BC. And the tan of 50 degrees is equal to the opposite over the adjacent, TOA, from the SOCA TOA, opposite over the adjacent. So opposite is 30 over BC. So rearranging this, I will get BC is equal to 30 over tan 50. Right? If I just rearrange this, I'll get BC is equal to, so the answer is D. If the live blurry, you need to click on the 3 arrows up top and increase the quality. This stream coming across on 1080p. It's supposed to be seeing main, HD by HD. Alright, let's keep moving. Right, so I want to do the question that was sent. If you want me to do a specific question, you can send it on the Student Hub Discord server. To get to the Student Hub Discord server, you just go to this on Instagram at this_Student Hub, and you click the link in the bio, and you will join the Student Hub Discord server. And there are already 10,000 students there from last year, and some from this year as well. So this server was started for exam students, and it just help people mash up exams, and it all the possible past papers and everything, solutions. Most of the solutions you'll find on the net, most of the solutions and past papers your teacher gave you all, it's stored in the Student Hub Discord server. Boom, big secret, all you know there. So the position vectors of A and B, so they had this question, I had to draw the question. I have to draw this question, boy. Why I didn't join the Discord on this iPad, so I just copy it, boy. And we want to know the point P. Hey, this question hard, boy. Who sent this question, boy? The point, this question is going to take some time. P is on OA, so this is a vectors question, such that OP is equal to 2PA, and M is on BA such that BM is equal to MA. So they want you to copy the diagram and include the points P and M. Well, yes. Next up, so all right, so send no more questions. Somebody want me to explain bearings and interquartile. I will explain the interquartile range next. Bearings just take some time to explain, boy. Or you might just be better off watching my whole videos on bearings. So they want me to redraw this and include point P and A. So let's think about this. What is called that kind of thinking? Critical thinking. P is an OA. Okay, P is on OA, such that O to P is 2 times P to A. So think about this. P is somewhere here. Let me see if I put P in the center, what will happen? So when people see 2P and think, they immediately think center. That's wrong. But let me see. O to P is the same as P to A, so that's wrong. You want O to P to be 2 times P to A. So it's better to divide this into 3 parts. So when you see in OP 2PA, that means 3 parts. And put P here. You are going to get a question very similar to this tomorrow, or these topics, vectors, bearings, matrices, these ending topics. One of the strongest videos on my channel are on these topics. So after this live, if you're feeling a little weak about that, just search my name, Kerwin Springer, on YouTube, and they might start to autofill too. And search the tough topics, quadratics, completing the square, and you can just learn in nice short form videos. Don't click on the live video that taking 2 hours, like these kind of videos, and then write in the comments, oh God, say you're talking too much. Click on the and really behave. Click on the short videos if you're trying to learn for tomorrow. Who knows, you might just scrape in a higher grade because of that. All right, so we put P on the diagram. BM is the same as MA, so it's obvious now that M is in the center because BM is the same as MA. The next part of this question I tell my class I'm going to send the link, and I forget to send the link, but I think somebody must have sent it by now. Yep. Yep. OB is produced to n such that OB is equal to BN. They didn't want to start drawing thing in this soul, yeah, boy. OB is produced to n. Let me write it out for you. OB is produced to n so such that OB is equal to BN. So in other words, we're lengthening out OB and going and try and hit N somewhere up the road there. So this diagram would have gone up a little more, and we have OB being the same length as BN. Why isn't it chat if you all understand that? How many people catch this? So don't forget to change it to 1080p so you could see me nice and HD. How many people catch that? And show the position N on the diagram, 1 mark. Expressing the terms of A and B, the vector. So these are the vectors we had to do now. We had to figure out vector AB, we had to figure out vector PA, and we had to figure out vector PM. Alright, one at a time, boys, one at a time. Let's not all rush. So some people get it, some people don't get it. The people who click in N, go and look up the topic vectors. It will, and then do some. After you learn how to do the theory in it with the short videos, you could watch the longer videos. This is exam for like 15-year-olds. Anybody, we always have a whole squad from India. This is exam for like 15-year-olds, and what we're doing right now is a topic called vectors. So if this, it may be either too easy or too hard for you, depending on where you are at. OB is produced and so we're trying to find AB, A to B. Wait now. Now this is capital M. Don't go and say AB is M. This is a point. This is el pointos. That M there stands for the point M. So AB. Anybody have an answer for AB? So somebody then say AB is M in the chat. AB, 15, 16-year-olds. AB is going this way. I can't believe somebody in the chat asked me to go for addition. AB, yeah, Isabella, nice, but you would want to use the common letters, right? So if I'm going from A to B, assuming, let me just check the diagram to make sure, because I didn't put an arrow, but assuming B means this direction. If I want to go from A to B, I don't know what it is, but I can go the alternative route, where I go like this. I go from A to O, and then I go from O to B. Yeah, you all catch that? O to B. And A to O is negative A, and O to B is positive B. Why is it negative? Is because I'm going against. So my working for that, I can be like AB is equal to A to O plus O to B. And then this is equal to negative A plus B. So I can write it as B minus A. Nice. The next vector that we need to find is P to A. Now P is over here, and we're trying to go P to A. This one is a little simple because O to A is A, and P to A is 1/3 of O to A. You see that? This is divided by three parts, and we're just trying to find this little part here, 1/3. So PA, my working for that will be something like PA is equal to 1/3 of OA. So this is 1/3 A. Now this is not how I am. teach. If you want to get like a full lesson or anything, you would have to register for one of my classes and I could explain and we go through long. I'm just speeding up the process, right? This is not, if you know zero, you cannot become a hero by just watching this video and pass maths. Although some people is write that in the comments of my video, they just watch these videos overnight and they get a 1 in maths and thing. You mightn't be that person. Right? So please disclaimer. I just want to put that out there. PM looks a little more confusing. PM. So we're trying to do PM, which is this really. It's from P to M. But the way we could do it is if we go like this and then like this. Or you could go like this. But that's something like more bacchanal. So you could go PA and then AM. Well, yes. How are we doing this, people? P to A and then A to M. But do we have anything for AB or BA? Yes. We know that A to B is B minus A. So you understand that? A to B is B minus A. So A to M is really B minus A divided by 2. And P to A was 1/3 A. We just find all those things. So we can say now, and I hope my head don't block this. Let me just shift everything up a little bit there, bro. Hope it's not too small for you. Are we trying to find PM? PM is going to be the 1/3 of A plus B minus A on 2. All right. Now, this M is not A to B. This M is a point. We could simplify this. Yeah, right now I'm using OBS. We can simplify this if needed. 6 2A plus 3B minus 3A. This simplification is a little, I get the LCM of 3 and 2. 6. I said 3 could go into 6 2 times, so I multiply the top here by 2. Else 2 could go into 6 3 times here, so I multiply the top by 3. And then I will end up with 3B minus A on 6. Is there anybody in the chat understand this last part of the question? You could get a question similar to this tomorrow. It wouldn't be as rough as this. That's correct, Isabella. That's another way of writing it. And Rahel. So we have some people understand it. Nice. Vibes. Now this is not all the question. The question went on with some more parts here. Using a vector method, show that P, M, and N are collinear. So when you've done a vectors question, they will either ask you to do the bulk of the question is either doing something at OB and them kind of thing, or using the triangle law AB, and then the next part of the question could be using the U and the V, maybe a parallelogram or a triangle like this question, and this is U and this is V, and they give you some points P, Q, R, S. So that's the bulk of your vectors question. But occasionally there's a little piece they add on, and in this piece they either ask you two things. They either ask you parallel or collinear, to show that 3 points are collinear, or to show that 2 vectors are parallel. This is how the vectors question come all the time. For those who have a good grip of it, you could start to put this, or those who do in exams in May, you could start to put this structure into your vocabulary for maths here. This is how it's going to come most of the times. All the time, actually. There's never been a vector question different from this, where you're either using this, you're either using that, and then you're finishing off with parallel or collinear. It's always that. So this part here, students always confuse how you're going to say how it's collinear or how you're going to show that it's parallel. So I'll start with parallel first, although this question asking for collinear. And I'll just use two random vectors. Let's say this vector is AB, and this vector is PR. To show that these two vectors are collinear, you're going to use either this term, scalar factor or scalar multiple. You can just write this word down. You can just write this word down, these words down, and you might just get a lucky mark. If you write it properly, like you write PR is a scalar multiple of AB. Boom, you get any mark for parallel. You mightn't get any mark for showing that how it is a scalar multiple of each other, but you get any mark. You hear the words I use, right? If I'm talking about multiple, I can be like 6 is a multiple of 3. 12 is a multiple of 3. So the bigger is a multiple of the smaller. So that's if you're using multiples. Some teachers will teach multiples, some teachers will teach factors. If you're using the term factor, then you could say 3 is a factor of 12. 6 is a factor of 12. So you could say AB is a scalar factor of PR. Alright? And here's how the letters will work with this. You may see something looking like this. There's a really complicated one here, but generally it's be something looking like this. You might see maybe this vector, you found this vector to be U and this vector to be 3U. Or if you're using numbers, you found AB to be 1, 5, and you found PR to be 3, 15. Catch that? So it's obvious that AB is a scalar factor of PR. That's how you're proving parallel. So I'm asking you all to do me a favor, or well, do other students a favor. Take a screenshot. Tag me in it. You can tag me in it to @KerwinSpringer on Instagram and post and say you're studying, and let some more people jump in. So people who get frightened and in tears and things, this is one of the hardest questions on the paper. This doesn't mean you're going to fail. This just means you may not be able to do the hardest question on the paper. So this is the last part of one of the hardest topics. So, excuse me, that's for parallel. That's the terms you want to use for parallel. If you want to see it done properly and quickly and systematically, search Kerwin-Springer vectors. Go and look up that video after that. Write it down. Write down that. If you had to go and look up the video and vectors afterwards, you'll see me do a past paper example and show you how to do it. That's one. Not Twitter, but I'm on Twitter. Well, I'm on Twitter, but I just post one set of random things on Twitter. Twitter have nothing to do with anything that I do. Collinear, now remember I said there's two things that come. They're either parallel or collinear. If they bring collinear, first you need to show the parallel, and then you need to show something else. You need to say, so if they bring collinear, you need to show that two vectors are parallel to each other, and then you need to say the points, they share a common point. Alright, and behind my back right now, a common point. I'll bring it up. I'll move it aside a little bit. Remember this, especially people who feel like they're going to get one thing and they want to ace the exam. This is sometimes make you lose your mark. You don't know how to say the collinear. You know what collinear means. You know collinear means that the points lie on the same line, but you don't know how to prove it and how to write it. So you need to show that they're parallel and they show that they share a common point. So let's use this example. We need to prove that P, M, and N are parallel. P, M, and N, are collinear, meaning that they lie on the same line. It even looking so in my diagram. It looks so in my diagram. Oh yeah, this is the very... Who sent this question in the Discord, boy? This is the hardest vectors question. I think that came in recent times. Anyhow, you need to show that P, M, and N are collinear. So what you're going to do is show that Pm is equal to some scalar factor of Mn. I wonder if I'm making best use of my time doing this hard question, boy. So Pm, we already found Pm to be this. We need to find what Mn is. Do we have anything for Mn? We never found Mn. So you actually need to go ahead and find Mn. How much marks this went for? This went for a fat 4 marks. So you're not going to get collinear for 4 marks again. So, but collinear could come, but because the number of marks in the question is smaller now. This question was out of 15 marks. Your question is going to be out of 10 marks now. 12 marks, sorry. Mn is the same as, I'm going to just speed up, sorry for those, b minus a over 2, and you have b here. So Mn is b plus b minus a over 2. This is going to work out to be 2b plus b minus a. This is going to be 3b minus a over 2. Now compare this. We know what Pm is. We just found that Pm, even if you don't understand, you'll get to see the example. 3b minus a over 6. You notice how you're still seeing the same 3b minus a? 3b minus a, 3b minus a. This is Pm, this is Mn. So you can immediately say that Mn is equal to 3 times Pm. You could write this so they are parallel, or you could use the words that I said. Mn is a scalar, is related to Pm by the scalar factor 3. Right? Mn is a scalar multiple of Pm related by the scalar factor of 3. And last but not least, to get the final mark, you need to say they share the common point M. And I'll explain the reason behind this. Common point M, and then I'll go and do some more multiple choice, and then I'll come back to some hard questions. They share the common point M, so they are collinear. Why can you get away with saying this and get your full marks? Because if two lines are parallel and they share a common point, they must be collinear. Think about it. If I have two parallel lines, A, B, and the next line, let's say B, X, B, B, N, and I'm saying that A, B, N are collinear. I'm saying that B and N parallel and A and B parallel. Well, and this is B, so it means that where this ended, this began. It means they are collinear. So I think I'm frightening people who not too sure about this part but could still pass maths. So I'm going to do some more multiple choice. Let me do some algebra. I think I did that on the first. Oh, I wanted to explain interquartile range. Let me just do that first. So there are some things to note in statistics. Let's see, these are age intervals. I was doing this recently with my online class actually. Let's say I have, what I want to use by 1 to 10, 11 to 20, 21 to 30, 31 to 40, 41 to 50. Sometimes they might give you tallies and you'll be like 6, or sometimes they might just jump straight to frequency. So you'll be like 2, 3, 5, 2, 1. I don't know what I have this next column here for, but this column could come in handy. So out of this, we can be asked a lot of things. Trying to bring back up my thing, boys. Yeah, out of this, we can be asked a lot of things. We can be asked to draw a histogram. I'm not too sure if I should do that last question, my people, right? And we can be asked to draw a cumulative frequency curve. We can be asked to draw a frequency polygon. I'm feeling like 100% sure one of these coming tomorrow. Maybe this one. In the last dispensation of this maths exam, they keep bringing pie charts, which was a very rare thing. So chances of this coming again just real slim. So either you're going to get something easy like a bar graph, which is really easy, or a line graph, or you will end up getting a cumulative frequency histogram or frequency polygon. So you need to must learn this. Once again, this topic, you can write it down. I have videos where it's not a live video like where I'll be distracted here. It's me doing a video teaching histogram, cumulative frequency, I think frequency polygon too, and you can look it up. Pie charts was very rare until it came 2 times in a row. Histogram, cumulative frequency, frequency polygon. Which one you all want me to do? Which one do you want me to do? So the chat have a little delay, so I'm gonna wait to come up. I know they don't like maths and thing, but all you could press like on the video, cause just show some love now, man. So somebody asked me to explain this in the Discord server, so I'm doing that. Woo, somebody sent completing the square afterwards. I feel I'll do that. Cumulative frequency wins out. So the cumulative frequency, I have a sweet video on that. You can check it out after. You're generally going to get a graph that looks like this, because the data, small here, big there, small there, a cumulative frequency curve will look like this. So in the cumulative frequency, what they're going to do, what CSEC is going to do, is give you an additional column, very likely, called the cumulative frequency. And some students who didn't study is be confused with what to do in this column, because they will start it off with a 2, and then people don't know what to write here, there. So in this column, you just add in on. So 2 and 3 is 5. 5 and 5 is 10. You understand why it's called cumulative frequency now. And 10 and 2 is 12, and 12 and 1 is 13. Some people looking like they could use lessons. Y'all, my lessons, I try to make it very affordable, and it have some people here in my lessons, they could let you know. I go all out to give you as much value as humanly possible in that lesson. So if you're interested in joining my lessons, 0619. You can do that, join now. If you join now, it's going to be $300 a month, because you're going to get all the information we do before. If you join and the next time we start back, because this class started in July, our class started last year July, is just $200 a month, right? All right, so this is your cumulative frequency here. This is what you're going to plot on this axis. Now forgive me whilst I just ratchet this to make my graph look a little better, because normally a number here is finished off at 100 or 50 or something like that. So let me at least finish off at 20 now there. So let me make it look a little good. So how much more needed? Let's still make this 2. Let's make this 6 instead. Let's change this to 8, 2, 1. I need 1 more. So, brother, you get to be 3 now. yeah, so that would give me a better cumulative frequency curve. So this is 2, this is 8. So I just change the initial values. This is 16, this is 19, and this is 20. Make sure that this number that you finish off here is how much participants in the survey, how much things in the survey. Ting, 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 ting. All right, so 5, 10, 15, 20. All right, we could do better than that. 5, 10, 15, 20. 5. So normally, because they try to speed up the process, if they're testing graphs, they're testing graphs. If they're not testing graphs, they will probably give you the graph to start with. And so this is your cumulative frequency axis here. Cumulative frequency axis. And over here, we're going to get our intervals, class intervals. Actually, yeah. But instead of putting it like 1 to 10, like some people will be inclined to do, is actually a whole number line going down the road here. So 50, fine. 50. So you gonna be out 25. Okay, that was kind of 1, 2, 3, 4. So 10, 20, 30, 40. So the question is, with histograms, you're using the what we call let's call that the upper class boundary. Using the upper class boundary, yes, the chances of you drawing this, if you get cumulative frequency, chances of you having to draw the graph is high. So you're using the upper class boundary for histograms. Then you're using the midpoint for frequency polygon. So histograms look like this, where they touch. I have a video on Instagram, people, you could go and check it out. People who getting panicking and thing. A little panic breed. It's all who didn't study and wait till the last day. You know? So just face it like a man, face it like a woman. You could just go and look up the videos on Instagram. So, and if you watch my video on Instagram, you'll see numbers like 10.5 and thing here. You're using the upper class boundary and the lower class boundary to define the cut. Now, some of you all may be wondering, what is the upper class boundary? The upper class boundary here is between these two. 10.5. This is the upper class limit. Limit. This is the boundary. Lower limit, lower class limit, upper class limit, upper class boundary for the first interval. So it will be like 0.5 here. So what you're going to do is plot. You're going to plot the upper class boundary against the frequency. Upper class boundary against the frequency. When last I do cumulative frequency, but I am 100% sure about that. Or they'll forgive me, why so I just go and double check on this. So what I'm going to do is check my video on cumulative frequency, and you're going to be in a nice dance. For group data, you always use the upper class boundary because it will cover the class from before it. Yeah, boys and girls. Yeah. So you're plotting your cumulative frequency against your upper class boundary. The reason you always use your upper class boundary is because the upper class boundary includes the class that comes before it. So like this is 10.5, 20.5, 30.5, 40.5, 50.5. So I'll be getting like a little smudging you know, away from that. So 10.5, let me just put some dots here. Kind of miserable to draw with no graph page, but I didn't want to go through the whole process. If you want to see me do it with a graph page, just look up the video. So I just put in these lines to guide me, so my thing come out kind of accurate. Yeah, so the question for CXC comes very similar to this. These values that I make up. So you notice how my gray lines, no, you don't draw these gray lines, eh? People just, any last minute, go and check my video on cumulative frequency if you're doing it. I just pretending that like I had grid lines here and I can see what I'm doing. That's why I put the gray lines, right? The first point is 10.52. Well, that's not really the first point, but 10.52, that will be somewhere here. Now, always use X's. Some people just use dots like this. Some people use dot and circle, which are allowed, but I just telling you to use X's. I know why I'm telling you that. Just take it and use X's, right? The first point is really here. First point is really 0.50, right? And the second point is 20.58. 20.58 is somewhere about here. So next point is 30.516. Somewhere there. So then 40.519. You understand? 40.519. That's how your cumulative frequency goes. And next one finishing off at 20. And then all you need to do now is come like a boss and connect your dots. And make sure you got a nice smooth curve. Your curve should look like that. Sometimes it don't look too good. Sometimes it kind of thing. But you ain't expecting to see this. If you're seeing this, foolishness, you do some kind of nonsense. If you do this, now we taking that. No, not 2. Don't beat up. They ain't gonna kill you for that. 10 divided by 2. Whoa, a stick, a back. I'm gonna see myself and see where. A back. I don't think I'll miss anything important because when I look up, I'll now say freeze. So I think I'm good. Yeah, so what I'm doing, if I think I just mentioned this, median interquartile range probability. This is what comes after you have to draw the curve. Median interquartile range probability. And if you need to find the median, you find the middle of your cumulative frequency. 10. Now, the middle is 20 divided by 2, but in some places they'll say 20, n plus 1 divided by 2 to get the Q. I'll explain the Q2, what Q2 means, which is the median. I'll explain that a little more just now. But in some places they say n plus 1 in some books. But sometimes in CXC, you see they just use 20 divided by 2. So you could just run with your 20 divided by 2 in this case and pull this down. Now, the common mistake is that some people will say the median is 10. The median is not 10. We want the median age. So after you get the 10 and you bring it across, you need to come now and pull it down. A little bendy, but we can live. So your median age is really whatever this was. So this might be 22. Let me say that was 22. It means your median age is 22. Now let's talk a little bit about the interquartile range. Fondly called IQR. Interquartile range. So when this comes, it come and just slap people who don't know anything about it. Just plow, right? And they lost that 2 marks one time. The interquartile range is really something Q3 minus Q1. And the full explanation for this may take like about 30 minutes. So what I'll do is just give a short, quick explanation. When you have a group of data, the one in the middle is called the median. That's called Q2. That's the second quarter. If we divide this data into 4 parts, you'll have Q1, Q2, and Q3. This is the median of the first half of the data. And this is the median, Q3, of the second half of the data. Have no leaks. So Q1 is in the middle of the first half of the data. So Q1 is like the median of the first part, and Q3 is like the median of the second part. You understand what I'm saying? So like if you had 3, 4, 5, 7, 9, 10 as your data, the median is 7. Let's just add in an extra one there. The median is 7. Now, if you had 2 in the middle, you had to add it up and divide by 2, but I didn't want that to happen. So the median is 7, the middle term, and don't forget to put it in numerical order first. And so this is Q, what we call Q2, the median. And if you're trying to find the Q1, it will be these two divided by 2. The Q1 will be 4.5. The median of this first half of the data here. Now, some places will see 4.5. Some places you will see they ignore Q2 and they just take this. There's some discrepancies in the convention for IQR. Right? I just putting that out there. I don't know. And I don't know. The syllabus doesn't be very clear on it either. So this is the median. The median of the first half of the date, this was a 1, is there. And then the median of the second half is these two divided. Oh, no, this wasn't anything. So is 4. All right, this just look like one stand numbers with X's and circles in them. For the interquartile range, if you want to learn your interquartile range, you can check out my video on interquartile range. If this wasn't that helpful to you, I just try to show a quick kind of concept there of how it works. So in this case, to find your Q1, you catch the idea there. I divide the data into 4 equal parts. Q3 is up here, and this is Q2. Now, once again, some places have Q1 would be this plus 1 divided by 4. N plus 1 divided by 4 is Q1. Especially if you have raw data, yes, use this formula. That's especially where I see this formula being used. Q1 is equal to N plus 4, N plus 1 divided. It's like you get the first quarter of the data, where the first quarter of the data stops. The last quarter of the data would be up here, but nobody care about no Q4. That's the final thing, right? So the interquartile range, some people will say the interquartile range is Q3 minus Q1, and they will just, people who kind of understand, they will just end up with 15 minus 5 equal 10, and you fail. You fail that question. The reason being, you still need to come down and read it off. Why I can't draw these straight lines, why? A little rusty. So let's say you got 16 here and 26 there. No, I don't want to get the same 10. Let's say you got 17 here and 26 there. This will be Q3. The Q3 is 26. You read off down here. And the Q1 is 17. I'm doing it quickly, guys. I'm sorry. Like, I'm feeling very bad that I can't spend time and really explain this like how I should be explaining this if you're learning this new. This is supposed to just be revision, and I've seen a lot of people in the chat like mind fried and all kind of thing. But I know it's helping some people out there. So 26 minus 17, 9. So this is what we call the interquartile range. the interquartile range. So I can see it there. So that's the next part that usually comes in a cumulative frequency question. Rates out of 10, how ready you feel you are for the statistics question. And the final thing that could just pop out on you in the statistics question is probability. But for the last 15 years, for the last 20 years, CXC has been bringing probability extremely easy, and I don't think they will switch it up on you. Like, if you could reach here, you're going to get that probability question out, unless they make a little simple mistake or something. So how they'll ask you the probability, a person chosen at random, let me give you the trick, at random is older than 40. This is a very simple question with one deadly trick in it. So they will ask you for the probability that a person chosen at random is older than 40 or more than, or if it's I don't know what it is. If it's usually be age in cumulative frequency, but it could be other things too. It could be like other things. any variable, right? Any continuous variable. Years, time. So probability what Venita is putting there is correct. The desired outcome over the total possible outcome. But how we finding this one now? The probability that a person chosen at random, and you have to use the graph, is older than 40. Anybody have an answer? Some people saying 7 out of 10. So it's a simple question, but how? Let me show you how you do it. By the way, all these questions done with past people. If you search Kerwin Springer cumulative frequency, you can find a video with me taking my time, not in a live video, in a recorded video, just going through the question and you can mash it up. What happened in here? What happened in here, boys? A person chosen at random is older than 40. So we need to go up the 40 line. This is what you have to do. Swing up the 40 and see how much people older than 40. I'm going to show you all the mistake people make when they kind of understand this. So they swing here and they get what? 19 or 18 or how much it was. I think it was 19 anyhow. So they swing there and they get 19, right? Or maybe 18, depending on how your graph looking. So let's say it was 18. According to my graph, it should be 19. All right. Let me put 19. Somebody want me to do harder topics. So what people will say, the probability is 19 out of 20. That's wrong. So there's 19 people younger than 40. So you have to watch what they're asking for very carefully in this probability question. If you understand it, don't lose a mark. Don't lose a mark silly in this question, right? Keep in mind I'm teaching somebody harder topics in maths right now. So the probability is actually 1 over 20. And probability can be given as a fraction. You understand? So this is, you go up the age 40, you read it across, you get 90. You see between 90 and 20, there's one person that's older than 40. So the probability that a person chosen at random is 1 out of 20. Or you could express this as a percentage or as a decimal. Probability can be expressed as a fraction, percentage, or decimal. All right. What y'all think about that? You feel like you're ready for this thing, boy? So let me go on the Discord, see why people asking for harder topics. Is that so? All right, so here's a harder topic. This is quadratics completing the square. This is a little harder. They kind of bracing on it from this topic for a while now, so there's a chance that this can pop tomorrow as well. After I do this, I want to do some multiple choice to finish off. the reason I'm finishing off a little early is because I already have lots of stuff on the channel. And if I stay here, you all will stay here. And some of you all need to go and look up at specific videos. -5, -1, 0, 5, x, y. Somebody saying not so hard. State the roots of the equation. So we want the roots and this equation according to them. X squared plus bx plus c equals 0. So what are the roots of these equations? Wait, that was b and a c? I'll look back on that now. X squared plus bx plus c. So what's the roots? Right, Faith done put it out there. So very simple. The roots is -1 and 5, because the roots is where it cuts the x-axis. So I can't talk now. The roots are where it cuts the x-axis. So they actually give it to you on the diagram. Now, if you only learn how to do this like just one tunnel vision, I just learn how to complete the square, I learn how to find h and k using a little formula, and you don't really know what is roots and things, they hit you for 6 in this question. And this is a very easy question, because they literally asking you to state for 2 marks. So state roots. The roots are x is equal to -1 and x is equal to 5. For the function y is equal to determine the value of c. So do I have to get the value of c now? What is c? So somebody sent me this on the Discord channel. What is the value of c? -5. C is where it cuts the y-axis. In this case, c is the y-intercept. So the value of c is equal to -5. Then, or determine the value of c is the y-intercept according to the graph. Show that b is equal to -4. So show that b is equal to -4. This is a little tricky. How are we going to show that b is equal to -4? How are we going to show that b is equal to -4? This is not something that your teacher may have taught you. So this, you might, some people in maths, like only what I've been taught specifically I can solve. But like if I have to think about it, fire burn. So how are you going to figure out what b is? Plug it into the format. Put it in the equation, and if you get the same roots is correct. Yeah, you could do that. So I think that might work. There's a faster way. So you say put it -4x, and we already figured out this, and then you factorize, and since we get the same roots, yeah, as a teacher I would give you the marks if you do that. Draw a broken line across the 4. No. Complete the square? No. If you complete the square, you're doing one star extra things there, and you still might even figure out what b is. The fastest way to do it is use the roots and say, well, x plus 1 and x minus 5 is equal to 0. Because if these are the roots, then these are the factors. Because remember, when you reach this scenario, it'll be like, therefore, x is equal to -1 and x is equal to 5 is x minus 5 equals 0, and then you bring across. You all remember that? Or I'm talking to myself here. So the fastest way to do this may be to use the factors and expand. So you end up with x squared, you'll end up with -5, you'll end up with x minus 5x equals 0, and x squared minus 4x minus 5 equals 0. Therefore, B is negative 4. Why isn't each other together? All right, so let me do some multiple choice to close off. I'm actually using my book here to help you already multiple choice. This is the question bank. Pick a topic, we'll do it. So those of you all who are watching this in May, you just go to this website, www.thestudenthub.com. Those of you all who are watching this for the next exam, what I'm doing it anyhow. All right, I lied. www.thestudenthub.online. Boom. And you can let us load. You can buy the question bank here one time. Right? You can buy a question bank, you can buy the SBA bank. This book, for those of you who are doing SBA, this book is like, I don't want to use the word cheat code, the phrase cheat code, but this is like it. People who have bought this book have come back to message me and say, sir, you saved my life there. So this book has like 20 SBAs in it, and I go through specifically how to do the SBA for CSEC. So if you're doing SBAs and you're going to do exams in May, get your hands on this. If you don't have a credit card and you wouldn't be able to buy it, right? Like, so if you don't have a credit card, just WhatsApp this number and you could, like if you're from Trinidad, it have other ways you could pay. Like direct, 1-868-790. Not this one, not this number. 868-784-0619. Most of these students in my classes already have these books, but this is more for YouTube people, right? That's the book I'm using to pull these questions from. So what do you want me to do? What topic? Sets. Somebody says sets. All right, let me see what we have on sets. Now, you know sets could only come in multiple choice, right? So make sure you can do your sets question. These are all the possible styles of set questions that CXC brings. If A is that, this is a real common question. This first question. See this first question there earlier? This number is 2. I don't know why it isn't showing. I erase it. Shucks. If you have that and you have to determine the number of subsets, that's like that question going and come tomorrow earlier. That question going and come tomorrow. If A is equal to, and you have these 3, A, B, C, then the number of subsets of A, well, 2 to the n. Well done, Rahel. You know your thing. 2 to the n, where n is the number of items, the number of elements, members inside the set. So 2 to the number of 3 is 8. So the answer is 8. If there were 4 terms, it doesn't matter if the term were numbers. The number of subsets is 2 to the power of 4, 16. There was one, I think, with 5 terms at a time. M, N, L, M, N, O, P, Q. Sometimes you start off in the middle of the alphabet and you don't really know where you're going. I teach maths. So this is 1, 2, 3, 4, 5 items. So 2 to the power of 5. There are 32 possible subsets here. What some people is find themselves doing, they didn't really learn it, so they come now and they're checking it out. A, B, to determine how much kind of subsets they could build now. C, alright, and then maybe you could get A, B, and they might make the mistake and put B, A, which is the same as A, B, so they're going wrong there. Or B, C, and they get 1, 2, 3, 4, 5, 4 closest. But you're missing out real sets there. You're missing out the empty set. You're missing out the set with all in them. 1, 2, 3, 4, 5, 6, 7. I'm missing out one more set. A, B, B, C. I'm missing out A, C. So they're actually A sets. So it kind of hard. It is harder to try and figure it out by listing out all these subsets individually So the best bet is to know your formula, 2 to the power of n. There are 3 terms here, so 2 to the power of 3 is 8. If p is equal to that, then the number of subsets of p. This is the next tricky one. So if you have an empty set, how many subsets you have here? So you see no numbers there, so you might say there are 0. There are 0. But 2 to the power of 0 is actually 1. So the number of subsets you can get is actually 1. B is not A. The answer is B for number 2, believe it or not. And the reason for that is because an empty set is still a set. So this is still 0. Nothing is still something. That's be the whole argument for people who want to know what happened before the Big Bang. If the Big Bang was creation, and there was nothing before that, but nothing is something, you know. So anyhow, so if P is X, then the number of subsets in this scenario now, and next way you could get carried away is be like, this is 1. Hold on there, let me just boot this person. Alright, my mod's just handling these people. Right, don't afraid to time out people who eating and think too much out here. So the number of subsets is not 1. The number of subsets is actually 2 in this case, because it's 2 to the power of 1, which is 2. So this formula would save you 2 to the power of how much items? 2 to the power of 1 is 2. Now the reason we get 2 is because there's the empty set and then there's the set with the X in it. 1, 2 sets. If the universal set is this and H is this, everything outside of H complement is what? This is the universal set. This is H. This symbol here means H complement, which means everything outside of H. So we just getting rid of the QRS. So PTU, we're looking for the set with PTU. This is C again. Why is in the chat if you find that was cool or you understand that? That was easy, mash up the place. Let's do a Venn diagram question now. Which of the Venn diagrams below is the region outside of P intersect Q? P complement intersect Q. Everything must be, so outside of P and part of Q at the same time. So this wrong. So it has to be one of these two. The reason I know these two wrongs is because it has to be outside of P in the first place. So if I see shading in P, forget you. So outside of P and in Q at the same time, this still have a little bit of P in it. So the answer has to be C. A lot of C is going on here, but this is the time where you get suspicious. You have your thing going down the road, so your answer sheet. And if you find you shading the same thing over and over, it's something looking wrong. Alright, let go. Next question. What is the region shaded in the diagram below? What is the region shaded in the diagram? Well, this I don't want to say it is a CXC question before CXC come and say, yo, you giving out the multiple choice question. But earlier, this kind of question is happening all the time. I can just say it that way, right? So, everything outside B. So the answer is C. C again. Everything outside of B. Because B not getting shaded, so this is everything outside of B. And I even bothering to watch the other stuff. By the way, I hope you know, yes, this mean intersect, this mean union, this mean complement, this mean how much, the number of elements in B. I hope you know your symbols for sets. If the universal set U is whole numbers from 1 to 10 inclusive, words by words. If the universal set U is whole numbers, this are too much words for mathematics. Forget that question. All right. Whole numbers from 1 to 10 inclusive, E is even numbers and P is prime numbers. Then the number of elements in even intersect prime. Well, yes. Look at Bacchanal here. So U is the whole numbers from 1 to 10 inclusive. I've seen the answer, but I want you to see it too. And E is the even numbers. So here's your even numbers. So 2, 4, 6, 8, 10. This is our next common question, I think, too, you know. They like to bring this prime numbers, even numbers talk. And they want you to, what they want you to do by prime numbers, even numbers. Then the number of even intersect prime. Oh, let me show you the prime numbers. The prime numbers are 1, 2, 3, 5, 7. So where do we get an overlap between prime and even? This is actually asking a very simple question. There's two ways this question come. Whole numbers from 1 to 10. Yeah, but they say from 1 to 10, bruh. So we're not going to put 0. So 1 to 10, inclusive. So put 1 and 10, but don't put 0. Even though whole numbers mean 0 too. I don't know why they put whole numbers. They could have just put natural numbers. Whole numbers, they type in head. Anyhow, there's two ways that this question could come. They could ask you, list the elements of E intersect P. And if you have to do that, the answer is 2. Because the only prime number that's even is 2. But, see, a lot of people saying C. That's not what this question is asking. Most people saying C. And I could snap this question and post it on my Instagram and watch people get it wrong. They're asking for the number of items in even numbers intersect prime numbers. And that's 1. There's only 1. This is 1. Because there's only 2 there. It's confusing, right? 2 is the only even number that is prime in the world. But also in this set. The only even prime number. So the number of elements in even intersect prime is actually 1. This n here change everything. And there's 2 ways that it come. They could ask you the number of, or they could ask you to list the even numbers. Right? Tricky. Watch out for that. You see this? Watch out for that n. Very tricky stuff there. Watch out for that, please. Don't get thick. So these sets questions that are helping you all with spending some time on sets, because on the channel I don't have much on sets because sets only come in the multiple choice. Very informative. I hope all you're paying attention. We already do questions that will probably show up in your exam on that sets thing. So, but some of you all, based on what I see in here, definitely need to spend some time. Definitely need to spend some time going through some of my core videos on the channel, like vectors, matrices, cumulative frequency statistics, bearings, trig, circle geometry. All of those, I have lots of good stuff. Good stuff. I don't put nobody in timeout. I have admins, so if you're just talking consistently and you're spamming, you will get put in timeout. Prime numbers, even numbers, odd numbers. Okay. So why this capital, and this common? Editor, which of the following is an empty set? Oh. Prime intersect even. That's not empty. I could ask which of the following is true. Prime intersect even is not empty. Prime intersect odd is not empty. There are many odd numbers that are prime. In fact, most of the odd numbers most of the prime numbers are odd, all except 2. Every number that is not prime intersect odd. This is also not empty. Odd numbers intersect. There's no odd even numbers, so this is true. So D. There are no odd numbers that are even. Either you're odd or you're even. You cannot be both. If P and Q are 2 sets where, all right, this is the final thing that really comes in sets. Is this the last question? No, I have a lot more questions. What the hell, boy? Wait, sir. Well, yeah, go and download the book. If P and Q, this is a pop, but this is one of the final frontiers in sets, because it's kind of making use of, there's a big formula in sets that you need to know. Let me see if I can bypass using the formula. If P and Q are 2 sets where n number of elements in P union Q is equal to 16 and number of elements in P intersect Q is equal to 6, What is the number of elements in and number of elements in P is equal to 9, then the number of elements in Q. So the way how this thing go, people, the way how this thing go, there's A, there's B. I'm not using P and Q, I just want to explain how the formulas work. This is A intersect B, right? So they say that A union B what happened A4 boy? I'm running out of juice earlier. Other way around. Yeah. So this is the big formula. CX is by saying, so go and sleep. These people are going to have to take the L. So this formula could be interchanged. I could interchange these two terms. And meaning I could put the union here and put the intersect there, or I could put the intersect here and put the union here. This formula, you memorize this and you could just mash up these questions. So what it's saying is the number of this part here, the number of elements intersect A and B is equal to the number of elements in A plus the number of elements in B minus the number of elements in A and B together. And the reason given for this, the reason for this formula, to understand this formula, is because if I say A and I add it up, and then I say B and I add it, I will end up counting this area here twice. So I need to subtract it back out again. Or if I subtract A union B, I will end up with this area here. You could think about it, and I explained it, I think, in some, if you search up Cohen Spring and sets, there's a long video where I spent on sets and I explained this concept inside out. Somebody needs to put these exercises by retirement. He's doing this job. So how will these maths help us in the future? Maths like consumer arithmetic and statistics really helps, like if you own a business. The quadratics and things not going to help you in the future, you know. That's just there to see. That's just a challenge for the CXC maths. A lot of things you learn in maths you're not going to use in the future for CSEC maths. But the critical thinking does help. Like if an employer knows that you got a 1 in CSEC maths, they know you can achieve a certain level of critical thinking. But honestly, I am a maths teacher. I'm telling you, you're not going to use quadratics. Most of you are not going to use quadratics in life. You're not going to use no matrices in life. No. I'll be honest with you. So yeah, you can substitute now. This, what we're trying to find, we can rearrange this and I don't want to say rearrange, change the variables to P and Q. Number of elements in P plus number of elements in Q minus the number of elements in P and Q. And you can just put it in and get the missing number, you understand? So this was 6. This was 9. This is what we're trying to find. Let's call it X. Number of elements in Q, right? That's what we're trying to find. And this is 16. So what are we trying to say here, boy? We're trying to say 22 minus 9 is equal to x. 13 is the answer. When we rearrange, we'll get 16 coming across there. We'll add, you'll get 22. Take away 9. X is equal to 13. Why is in the chat if you get that? Why is in the chat if you feel you understand that? This is the formula you want to take away, right? Oh, I blocking? I wasn't blocking that much. I wasn't blocking. It wasn't that bad, to be honest. I hope I lean into the right side, the proper side. So I want to repeat. A lot of you all think you all need this last minute video and you will just go from not knowing anything as 6 to 1. That don't happen. That's only happened in my comment section. It's happened for some people, but those people is because they were revising all along and they come on the channel and they watch all the videos and it kind of refreshed them and they were able to pass. They had some revision from before. But if you don't know anything from before, I'm sorry, you may not be able to pull it off tomorrow. But, as I said, you can join my class. A lot of the people names I see in here, Kashmira, Tracy, Javish, no, not Javish, Javish in Form 6 now, Andwele, Emily, Chavez, Catalyse. A lot of those names are from my class, so they will know some of this stuff. 7840619. This is the number to register to my classes. And I started the Student Hub. Some of you are using the Student Hub Discord server. Some of you all are maybe in the thousands of students in the Student Hub Discord server. I started the Student Hub Discord server, but there's also the Student Hub premium lessons, which we have classes for CSEC, CAPE, same number. Any CSEC or CAPE class that you're doing, you can join. I handpicked those teachers that teach in there, and they are really good. A few weeks call it a night day. Anything else I want to do? I am from Trinidad. That's a country in the Caribbean. I know we have a contingent from India inside there. Renee, no assignment this week. No assignment this week. Everyone getting ones tomorrow. Let's go. So go. A lot of you all need to go forth and just learn from videos on this channel, and don't just learn and watch and learn. Don't just watch and learn, but write. Actually do the questions yourself. Coming in paper 2, yes, measurement comes in paper 2 as well. Circle geometry. Let me show you now. Someone need to see it with their own 2 eyes. If I go on YouTube like this, I mean I can do some live, yes, but a little tired. I'm thinking about it. If I go on YouTube and it load fast, come on YouTube, don't do me that. Hey, look, we live here, man. If I go on YouTube and I search Kerwin Springer circle theorem. Want something, eh? Understanding useful theorems. I'll open the video to open it in the background. This is me doing a whole set of circle theorems. This is an hour of me doing a whole set of circle theorems a whole year ago. This is a very good video if you now start circle theorem. So you watch this one, then you watch this one, and you'll see me going through a lot of circle theorem questions, breaking down the concepts. I don't know who is that earlier. This is some more circle geometry for AdMath students. Do not click on this; you become very afraid if you're not doing AdMaths. Yeah. So watch those videos. There are some more lives where I did circle theorem, but I didn't name it circle geometry. So it's there. It's just for you to go and look. I don't know why everything taking so long to load. So I go through how you approach circle theorems. I went through all the basics that you need to know. All the basic stuff you need to know about chord and this and that, and then I went through the advanced stuff, which is the circle theorems themselves, and I explained each one. And I didn't do any questions on them because the questions I do on them are in this video here. You can't go wrong. So that's what I was telling you. You just search Kerwin Springer completing the square. Kerwin Springer, bearings. Kerwin Springer, whatever, and you're good to Kerwin Springer completing the square, and you can see me doing past papers, you can see me doing the concept on it. It's sticking. It's sticking. Let me get a breather. Alright, people. Till we meet again, press like, close off the chat, press like, go and follow me on if you're not follow me on Instagram, especially if you're going to do exams in May, so you can keep abreast with how things going. And I try to motivate people and keep all in the game as well. I'm still frozen. Am I still frozen? All I said was to go and follow me on Instagram if you have not already. So you can keep in the game. I feel like I'm still frozen. Don't forget to close off the chat and drop a like. Don't forget people buying the book. You could buy the book if you want. Love and blessings. I will talk to you after the exam tomorrow. But it's still at 300 and something people here. Instagram. Especially if you're doing an exam in May. And as I said, I try to post motivating stuff and I'll kind of be focusing more on motivating stuff this year. A lot of people who get ones from last year here, I don't know what they're doing here. Or even if you get one, you done deal with maths already, you done pass. Let me end this stream. I feel like I have other things I have to tell you to do now. We call it call to action. If you don't remind people to press like, they don't press like. Sometimes you're saying press like, and people, it's not that they don't want to press like, it's just like, you hear that so much time on YouTube that just pass you one A and go the next A. But it's really help. If you press like, it's help more people to see the video and that kind of thing. So close off the chat, press like, you can bring back up the chat. For sure, follow me. Love and blessings, people. Enjoy your exam tomorrow. Enjoy being the keyword. I hope you completely mash it up and it does not mash you up. Till we meet again. Trying to figure out how to end it here.